Yeah, look at that problem, how it works in RStudio. Suppose you want to generate the 10,000 observation. So here I'm considering the different values of my alpha, okay? Because I need to be understand what to be my alpha values and all. Okay, so I'm considering my alpha is 1.5 and I'm defining here my function h. Okay, this is my function, which is e raised to, what is this? This is your h of x function, right? H of x function, x square by 2, x square by 2 plus alpha time absolute value of x. So let's run it. Yes. Now just create a sequence here because we want to just look at what value it is maximum. Okay. And calculate calculate the hx1 based on this function with a1 is 1.5. So this is your data for first function hx1. Look at this. So these many observations we have generated from that particular function h of x. Now you want to see the what will be the maximum value, what is the minimum value. So if you just look at here, it's very like -5 to, it's varying from -5 to maybe the positive value. Maybe there's some positive value, you can get it from here. So you can just look at the graph for this, it's become clear. Okay. Similarly, if you consider alpha ka value is 0.8, if you consider alpha ka value 0.8, just calculate just calculate hx2 at that point. Similarly, consider alpha ka value 2.5 and calculate again hx3. And now you plot hx3 having that limit minimum of h1 h2 h3 and maximum of h1 h2 h3. So based on the this function, it will consider minimum maximum. Okay. So this is the one graph. Let's draw this line first. And look at this picture. So here, if you just look at the maximum value, so it will be around -3 here, and again here it is 3. So -3 to +3 would be your actual at that point it is maximum. Okay, at that point it is maximum. So ideally that Sika value will be approximate that particular point. Because maximum of you want f of x upon g of x. We'll just check it this. Let's see whether it works or not. So we have this particular PDF, proposal PDF. Proposal PDF here. This is your target PDF. Okay. Let's draw this proposal and proposal PDF first. Okay. Look at this proposal PDF. So it is a toward your x values. Okay. So the shape become like it is inside. It is not outside. Okay. It's not outside. It's inside. But it seems to be the become a normal. But you can say it is if you just get the values of x. So what are the values of x we have here? These are the values of x we have considered, right? -5 to you can just consider suppose -10 to 10 here. Get this x value and now plot this. Okay, we have to compute this first. And look at this graph. So it is actually tending to the normal, but the shape is different. Okay, now let's draw for this. Look at the shape. So as my x is increasing, maybe here approximate the tail for proposal and tail for target is almost tending to same. Okay, it is not equal, it is tending to same, remember. Okay, but if you just look at the shape here, this particular shape for the proposal and for the target having a lot of gaps. Okay, so might be acceptance probability is less here. It will be below 40, below 30. It can be because it is not exactly the matching your proposal with your target. Okay, but just look at the shape. So shape according to that, at least it is little matching, not like the previous example. The previous example we have observed one graph will be like this, one graph will be like this, one graph will be like this, if you remember. Okay, but at least for this problem it is little matching, but we are not sure about whether it will give you the acceptance probability more than 50 or more than 70% or not. Okay, so if it is more than 60, that means it is good, means the proposal which we have considered is it is good and it is related to your target. Okay? Then you have computed here C. Now see here, look at the C ka value here. So C is coming here 1.3. Now here pi ka value by default it is assumed 3.17. Okay, so there is no change in that. Now let's create a loop for this first. I think this part we have to show it is we have to show that it is coming 1.3145. I will just share with you the practicals today so that you can get an idea how the practical problem is solved based on this. Just a second. So let's start with the counter. So k is 1. So if we are creating the empty vectors, okay. So empty vectors. And now we'll create a loop. So here, if you just look at the graph, if you just look at the query, we are having the two PDF. One, if it is less than 0.5, then we have certain observations. When if it is greater than 0.5, then we have certain observations generating from Y. Okay, so we have to write both the functions. So we use if. So under for loop, we have two conditions. We are generating from first U1, which is uniform. Then we have to write the two PDF. This is we have not written many in any of the following yeah, problems. But since you are generating from the proposal and they are invertible, that means inverse is exist for that. So we have to first generate from there. Okay. So if this condition true, then we take the value of Y. Okay. If this condition true, then we will take this value of Y. Right? And now we will generate U from uniform, R is usual your D norm divided by C time your this is right proposal let's check proposal is right or not.
Sir,
Yeah,
sir, alpha is 1.5. Then in proposal density, it should be 0.75. Alpha by 2.
C into your proposal. So have we written the proposal is right here? Just check it once again.
Sir, alpha 1.5 लिया है ना?
No, no, alpha is 1. Alpha is 1.
Sir, the point in bracket minus 0.5 is not there, only absolute value of it.
Yeah, that I'm thinking here. So if we consider the shear here, the 0.5 not coming, right?
Yes, sir.
Minus still there, right? Yeah, then now let's draw this. Shape almost same, it do not change much. See, it's more skewed. Lip. What is that? It's highly picked. So now if we just look at that, then almost there is a gap. That the gap is reduced because we have chosen the wrong that proposal, might that 0.5 because of that. But now if you just look at this, almost it is matching with your proposal with your target. Ready? So see, this is the way we have to analyze using that graph. Okay. Same that one because I just seen this because it is your what is that? This is your target into C time, target upon C time proposal. So proposal I just seen here 0.5 is not there. That means I thought maybe there is some mistake here. And then once you just find out the ratio of that, check with the condition. If that generated observation is less than equal to R, then that counter will be the your Y value and increase your counter. Okay, so just run this part. We have not run this. Let's run this first. Get this N. So it is 69%. It's a mistake, I guess, na? Because we're generating from 10,000, na? We'll run it once again. Yeah, not discount. So we may say that 75% is your acceptance probability in this problem. Means the proposal which we have chosen here, that is absolutely matching with our target PDF. Okay, you can look at the plot also for this. Now look at the plot of this and look at your plot of your target. ये क्या गड़बड़ हुआ इसमें? Just a second. Let's take -5 to 5. And read this, draw this line. Look at this. So what you can conclude here, students? Understand. What you can conclude? Generated observation from the proposal density is exactly matching with your target density. Are you getting the point?
Yes.
बोलो और क्या क्वेरी है किसी? So you may try out one more problem here. So this is the practical number 1. Okay, I will share the updated practicals. Okay, but these problems you have to consider. Just look at this. Consider the using acceptance rejection algorithm from the normal 0, 1 random variables from the double exponential distribution function. Okay, alpha by 2. So that is the PDF we have considered proposal. Show that the probability of acceptance is then this. So which you have obtained na, C ka value आपने निकाला ना, that is the probability of acceptance, and hence deduce that to produce the one normal random variable, this acceptance rejection algorithm requires on an average 1.3 normal variables. Okay, is the value which you have computed, that is the basically around 1.3 is coming now. So that is the on an average, it is on an average we require 1.3 normal variables, and then implement the acceptance rejection algorithm to generate the observation, which is around 1 lakh from the normal 0, 1. So you can do the same example which we have already done it here. Then this is another example. Consider acceptance rejection method. Now here we have considered positive normal density function, and proposal is this. Okay, I guess we did this one last class. So you can show them the constant term is this, implement again same. Then we have another example here which we did it already. Okay, you can practice this one, fourth one. Okay, just I'm giving here, which you can do it here right now. so that in one practical you have at least 4 questions. Write down. Just do it with me. Suppose we wish to generate random variables from f of x is equal to 20x in the bracket just a second, I'll stand values 1 minus x power to 3 0 is less than x less than 1 so this is my target PDF. I want to generate from this particular PDF. Okay, by considering you can consider, maybe you can consider uniform distribution, for example. Okay, assuming proposal is uniform 0, 1. Implement acceptance rejection method. Just try this. So first, what do you want to do that here? Just calculate f of x upon h of x. So which is going to be same only. I hope you are getting the procedure.
Yes, sir.
Yeah. So roll number 3 is present. 3, 7, 11, 12, 3, 7, 11, 12, 13, 22, 26, 27, 28, 30, 31, 33, 35, 36, 38, 39, 40, 41, 42,